Today we have the topic, Evolution of Java. We will get to know many things about Java. So let's start. We will cover these topics. Java history. Java features. How Java differs from C and C++. Java and Internet. Java and World Wide Web. Web browsers. Hardware and software requirements. Java support systems. Java environment. Java development kit. An application programming interface. Java history. Java is a general-purpose, object-oriented programming language developed by Sun Microsystems of USA in 1991. Originally called Oak by James Gosling, one of the inventors of the language. Java was designed for the development of software for consumer electronic devices like TVs, VCRs, toasters, and such other electronic machines. In 1990, Sun Microsystem decided to develop special software that could be used to manipulate consumer electronic devices. A team of Sun Microsystems programmers headed by James Gosling was formed to undertake this task. In 1991, after exploring the possibility of using the most popular object-oriented language C++, the team announced a new language name Oak. In 1992, the team, known as Green Project Team by Sun, demonstrated the application of their new language to control a list of home appliances using a handheld device with a tiny touch-sensitive screen. In 1993, the World Wide Web, WWW, appeared on the Internet and transformed the text-based Internet into a graphical-rich environment. The Green Project team came up with the idea of developing web applets, or tiny programs, using the new language that could run on all types of computers connected to the Internet. In 1994, the team developed a web browser called HotJava to locate and run applet programs on Internet. HotJava demonstrated the power of the new language, thus making it instantly popular among the Internet users. In 1995, Oak was renamed Java. Due to some legal snags, Java is just a name and is not an acronym. Many popular companies including Netscape and Microsoft announced their support to Java. In 1996, Java established itself not only as a leader for Internet programming but also a general-purpose, object-oriented programming language. Sun releases Java Development Kit 1.0. In 1997, Sun releases Java Development Kit 1.1. In 1998, Sun releases the Java 2 with version 1.2 of the Software Development Kit 1.2. In 1999, Sun releases Java 2 Platform, Standard Edition, J2SE, and Enterprise Edition, J2EE. In 2000, J2SE with SDK 1.3 was released. In 2002, J2SE with SDK 1.4 was released. And in 2004, J2SE with JDK 5.0, instead of JDK 1.5, was released. This is known as J2SE 5.0. The most striking feature of the language is that it is a platform-neutral language. Java is the first programming language that is not tied to any particular hardware or operating system. Programs developed in Java can be executed anywhere on any system. Java features. Java has these features: compiled and interpreted, platform-independent and portable, object-oriented, robust and secure, distributed, familiar, simple and small, multi-threaded and interactive, high performance, dynamic and extensible, ease of development, scalability and performance, monitoring and manageability, desktop client, core XML support, supplementary character support, and JDBC row set. These features have made Java the first application language of the World Wide Web. Java will also become the premier language for general-purpose standalone applications. Compiled and interpreted. Usually a computer language is either compiled or interpreted. Java combines both these approaches, thus making Java a two-stage system. First, Java compiler translates source code into what is known as bytecode instructions. Bytecodes are not machine instructions and therefore, in second stage, Java interpreter generates machine code that can be directly executed by the machine that is running the Java program. So, we can say that Java is both a compiled and an interpreted language. Platform independent and portable. The most significant contribution of Java over other languages is its portability. Java programs can be easily moved from one computer system to another, anywhere and anytime. Changes and upgrades in operating systems, processors, and system resources will not force any changes in Java programs. This is the reason why Java has become a popular language for programming on Internet, which interconnects different kinds of systems worldwide. We can download a Java applet from a remote computer onto our local system via Internet and execute it locally. This makes the Internet an extension of the user's basic system, providing practically unlimited number of accessible applets and applications. Java ensures portability in two ways. First, Java compiler generates bytecode instructions that can be implemented on any machine. Secondly, the sizes of the primitive data type are machine independent. Object-oriented. Java is a true object-oriented language. Almost everything in Java is an object. All program code and data reside within objects and classes. Java comes with an extensive set of classes, arranged in packages, which we can use in our programs by inheritance. The object model in Java is simple and easy to extend. Robust and secure. Java is a robust language. It provides many safeguards to ensure reliable code. It has strict compile time and runtime checking for data types. It is designed as a garbage-collected language, relieving the programmers virtually all memory management problems. Java also incorporates the concept of exception handling, which captures series errors and eliminates any risk of crashing the system. Security becomes an important issue for a language that is used for programming on Internet. Threat of viruses and abuse of resources are everywhere. Java systems not only verify all memory access but also ensure that no viruses are communicated with an applet. The absence of pointers in Java ensures that programs cannot gain access to memory locations without proper authorization. Distributed. Java is designed as a distributed language for creating applications on network. It has the ability to share both data and programs. Java applications can open and access remote objects on Internet as easily as they can do in a local system. This enables multiple programmers at multiple remote locations to collaborate and work together on a single project. Simple, small, and familiar. Java is a small and simple language. Many features of C and C++ that are either redundant or sources of unreliable code are not part of Java. For example, Java does not use pointers, preprocessor header files, Godot statement, and many others. It also eliminates operator overloading and multiple inheritance. Familiarity is another striking feature of Java. To make the language look familiar to the existing programmers, it was modeled on C and C++ languages. Java uses many constructs of C and C++, and therefore, Java code looks like a C++ code. In fact, Java is a simplified version of C++. Multithreaded and interactive. Multithreaded means handling multiple tasks simultaneously. Java supports multithreaded programs. This means that we need not wait for the application to finish one task before beginning another. For example, we can listen to an audio clip while scrolling a page and at the same time download an applet from a distant computer. This feature greatly improves the interactive performance of graphical applications. The Java runtime comes with tools that support multi-process synchronization and construct smoothly running interactive systems. High performance. Java performance is impressive for an interpreted language, mainly due to the use of intermediate bytecode. According to Sun, Java speed is comparable to the native C or C++. Java architecture is also designed to reduce overheads during runtime. Further, the incorporation of multi-reading enhances the overall execution speed of Java programs. Dynamic and extensible. Java is a dynamic language. Java is capable of dynamically linking in new class libraries, methods, and objects. Java can also determine the type of class through a query, making it possible to either dynamically link or abort the program, depending on the response. Java programs support functions written in other languages such as C and C++. These functions are known as native methods. This facility enables the programmers to use the efficient functions available in these languages. Native methods are linked dynamically at runtime. Ease of development. Java 2 Standard Edition, J2SE, 5.0 supports features, such as generics, enhanced for loop, auto-boxing or unboxing, type-safe enums, varargs, static import and annotation. These features reduce the work of the programmer by shifting the responsibility of creating the reusable code to the compiler. The resulting source code is free from bugs because the errors made by the compiler are less when compared to those made by programmers. Thus, each of the linguistic features is designed to develop Java programs in an easier way. Scalability and performance. J2SE 5.0 assures a significant increase in scalability and performance by improving the startup time and reducing the amount of memory used in Java 2 runtime environment. For example, the introduction of the class, data sharing in the Hotspot Java Virtual Machine, JVM, improves the startup time by loading the core classes from the jar files into a shared archive. Memory utilization is reduced by sharing data in the shared archive among multiple JVM processes. In the earlier versions, the data was replicated in each JVM instance. Monitoring and manageability. Java supports a number of APIs, such as JVM Monitoring and Management API, Sun Management Platform Extension, Logging, Monitoring and Management Interface, and Java Management Extension, JMX, to monitor and manage Java applications. For example, Java provides JVM Monitoring and Management API to track the information at the application level and JVM level when deploying a large application. Java provides tools, such as JConsole, JPS, JStat, and JStat to make use of monitoring and management facilities. For example, GUI-based tool called JConsole is used to monitor the JVM. Desktop client. J2SE 5.0 provides enhanced features to meet the requirements and challenges of the Java desktop users. It provides an improved swing look and feel called Ocean. This feature is mainly used for developing graphics applications that require OpenGL hardware acceleration. We have some miscellaneous features in Java. In addition to the above features, J2SE 5.0 supports the features such as Core XML support. J2SE 5.0 adds a powerful XML feature to the Java platform. Java contains some special packages for interface, to instantiate simple API for XML, SAX, and Document Object Model, DOM, parsers to parse an XML document, transform the content of an XML document, and validate an XML document against the schema. Supplementary character support. Java adds the 32-bit supplementary character support as part of the Unicode 4.0 support. The supplementary characters are encoded with UTF-16 values to generate a different character called surrogate code point. JDBC Rosette. Java supports JDBC Rosette to send data in a tabular format between the remote components of a distributed enterprise application. JDBC Rosette contains cached Rosette and web Rosette objects. The cached Rosette object is a JavaBean component which acts like a container. This object contains a number of rows of data, which are retrieved from the database. The data stored in the cached Rosette can be directly accessed without connecting to the database or any other data source. The rows of data that are retrieved from the database can be synchronized later. The web Rosette object can operate without being connected to the database or data source. The web Rosette object uses XML format to read and write the Rosette. How Java differs from C and C++. Although Java was modeled after C and C++ languages, it differs from C and C++ in many ways. Java does not incorporate a number of features available in C and CH. For the benefit of C and C++ programmers, we point out here a few major differences between C or C++ and Java languages. Difference between Java and C. Java is a lot like C, but the major difference between Java and C is that Java is an object-oriented language and has mechanism to define classes and objects. In an effort to build a simple and safe language, the Java team did not include some of the C features in Java. Java does not include the C unique statement keyword size of, and type def. Java does not contain the data types struct and union. Java does not define the type modifiers keywords auto, extern, register, signed, and unsigned. Java does not support an explicit pointer type. Java does not have a preprocessor and therefore we cannot use #define, #include, and #ifdef statements. Java requires that the functions with no arguments must be declared with empty parenthesis and not with the void keyword as done in C. Java adds new operators such as instanceof. Java adds labeled break and continue statements. Java adds many features required for object-oriented programming. Difference between Java and C++. Java is a true object-oriented language while C++ is basically C with object-oriented extension. That is what exactly the increment operator ++ indicates. C++ has maintained backward compatibility with C. It is therefore possible to write an old-style C program and run it successfully under C++. Java appears to be similar to C++ when we consider only the extension part of C++. However, some object-oriented features of C++ make the C++ code extremely difficult to follow and maintain. Listed below are some major C++ features that were intentionally omitted from Java or significantly modified. Java does not support operator overloading. Java does not have template classes as in C++. Java does not support multiple inheritance of classes. This is accomplished using a new feature called interface. Java does not support global variables. Every variable and method is declared within a class and forms part of that class. Java does not use pointers. Java has replaced the destructor function with a finalize function. There are no header files in Java. Java also adds some new features. While C++ is a superset of C, Java is neither a superset nor a subset of C or C++. Java may be considered as a first cousin of C++ and a second cousin of C. Java and Internet. Java is strongly associated with the Internet because of the fact that the first application program written in Java was Hotjava, a web browser to run applets on Internet. Internet users can use Java to create applet programs and run them locally using a Java-enabled browser such as Hotjava. They can also use a Java-enabled browser to download an applet located on a computer anywhere in the Internet and run it on his local computer. In fact, Java applets have made the Internet a true extension of the storage system of the local computer. Internet users can also set up their websites containing Java applets that could be used by other remote users of Internet. The ability of Java applets to hitch a ride on the information superhighway has made Java a unique programming language for the Internet. In fact, due to this, Java is popularly known as Internet language. Java and World Wide Web. World Wide Web, WWW, is an open-ended information retrieval system designed to be used in the Internet's distributed environment. This system contains what are known as web pages that provide both information and controls. Unlike a menu-driven system where we are guided through a particular direction using a decision tree structure, the web system is open-ended and we can navigate to a new document in any direction. This is made possible with the help of a language called Hypertext Markup Language, HTML. Web pages contain HTML tags that enable us to find, retrieve, manipulate, and display documents worldwide. Java was meant to be used in distributed environments such as Internet. Since both the web and Java share the same philosophy, Java could be easily incorporated into the web system. Before Java, the World Wide Web was limited to the display of still images and texts. However, the incorporation of Java into web pages has made it capable of supporting animation, graphics, games, and a wide range of special effects. With the support of Java, the web has become more interactive and dynamic. On the other hand, with the support of web, we can run a Java program on someone else's computer across the Internet. Java communicates with a web page through a special tag called applet. In this figure, Step 1. The user sends a request for an HTML document to the remote computer's web server. The web server is a program that accepts a request, processes the request, and sends the required document. Step 2. The HTML document is returned to the user's browser. The document contains the applet tag, which identifies the applet. Step 3. The corresponding applet bytecode is transferred to the user's computer. This bytecode had been previously created by the Java compiler using the Java source code file for that applet. Step 4. The Java-enabled browser on the user's computer interprets the bytecodes and provides output. Step 5. The user may have further interaction with the applet but with no further downloading from the provider's web server. This is because the bytecode contains all the information necessary to interpret the applet. Web browsers. As pointed out earlier, the Internet is a vast sea of information represented in many formats and stored on many computers. A large portion of the Internet is organized as the World Wide Web, which uses hypertext. Web browsers are used to navigate through the information found on the net. They allow us to retrieve the information spread across the Internet and display it using the hypertext markup language, HTML. Examples of web browsers, among others, include Hotjava, Netscape Navigator, Internet Explorer. Hotjava. Hotjava is the web browser from Sun Microsystems that enables the display of interactive content on the web, using the Java language. Hotjava is written entirely in Java and demonstrates the capabilities of the Java programming language. When the Java language was first developed and ported to the Internet, no browsers were available that could run Java applets. Although we can view a web page that includes Java applets with a regular browser, we will not gain any of Java's benefits. Hotjava is currently available for the Spark/Solaris platform as well as Windows 95, Windows NT and Windows XP. So far as being a web browser goes, it is nothing special and does not offer anything special that most other web browsers don't offer. Its biggest draw is that it was the first web browser to provide support for the Java language, thus making the web more dynamic and interactive. Netscape Navigator. Netscape Navigator, from Netscape Communications Corporation, is a general-purpose browser that can run Java applets. With versions available for Windows 95, NT, Solaris and Apple Macintosh, Netscape Navigator is one of the most widely used browsers today. Netscape Navigator has many useful features such as visual display about downloading process and indication of the number bytes downloaded. It also supports JavaScript, a scripting language used in HTML documents. Internet Explorer. Internet Explorer is another popular browser developed by Microsoft for Windows 95, NT and XP workstations. Both the Navigator and Explorer use toolbars, icons, menus, and dialog boxes for easy navigation. Explorer uses a just-in-time, JIT, compiler which greatly increases the speed of execution. Hardware and software requirements. Java is currently supported on Windows 95, Windows NT, Windows XP, Sun Solaris, Macintosh, and Unix machines. Though the programs and examples in this book were tested under Windows 95, the most popular operating system today, they can be implemented on any of the above systems. The minimum hardware and software requirements for Windows 95 version of Java are as follows. IBM-compatible 486 system. A hard drive. Minimum of 8 MB memory. A CD-ROM drive. Windows 95 software. A Microsoft-compatible mouse. A Windows-compatible sound card, if necessary. Java support systems. It is clear from the discussion we had up to now that the operation of Java and Java-enabled browsers on the Internet requires a variety of support systems. These are some systems necessary to support Java for delivering information on the Internet. Internet connection. Local computer should be connected to the Internet. Web server. A program that accepts requests for information and sends the required documents. Web browser. A program that provides access to www and runs Java applets. HTML. A language for creating hypertext for the web. Applet tag. For placing Java applets in HTML document. Java code. Java code is used for defining Java applets. Bytecode. Compiled Java code that is referred to in the applet tag and transferred to the user computer. Java environment. Java environment includes a large number of development tools and hundreds of classes and methods. The development tools are part of the system known as Java Development Kit, JDK, and the classes and methods are part of the Java Standard Library, JSL, also known as the Application Programming Interface, API. Java Development Kit. The Java Development Kit comes with a collection of tools that are used for developing and running Java programs. They include Applet Viewer, for viewing Java applets. Javac, Java Compiler. Java, Java Interpreter. Javap, Java Disassembler. Java, for C header files. Javadoc, for creating HTML documents. JDB, Java Debugger. Applet Viewer enables us to run Java applets, without actually using a Java-compatible browser. Javac. The Java compiler, which translates Java source code to bytecode files that the interpreter can understand. Java. Java Interpreter, which runs applets and applications by reading and interpreting bytecode files. Javap. Java Disassembler, which enables us to convert bytecode files into a program description. Java. Produces header files for use with native methods. Javadoc. Creates HTML format documentation from Java source code files. JDB. Java Debugger, which helps us to find errors in our programs. The way these tools are applied to build and run application programs will be illustrated in next figure. To create a Java program, we need to create a source code file using a text editor. The source code is then compiled using the Java compiler Javac and executed using the Java interpreter Java. The Java debugger JDB is used to find errors, if any, in the source code. A compiled Java program can be converted into a source code with the help of Java Disassembler Javap. Application Programming Interface. The Java Standard Library, or API, includes hundreds of classes and methods grouped into several functional packages. Most commonly used packages are Language Support Package, a collection of classes and methods required for implementing basic features of Java. Utilities Package, a collection of classes to provide utility functions such as date and time functions. Input/output package, a collection of classes required for input/output manipulation. Networking package, a collection of classes for communicating with other computers via Internet. AWT package, the Abstract Window Toolkit package contains classes that implements platform-independent graphical user interface. Applet package, this includes a set of classes that allows us to create Java applets. The use of these library classes will become evident when we start developing Java programs.